Good afternoon, everyone. I hope you've all had a delicious lunch, washed down with something even more delicious. Moving on then to our final stage of the Risk and Safety Forum. I'm pleased to announce that we have Dr. Philip Rogers with us. He'll be presenting online. Philip is the technology leader for hydrogen at the National Nuclear Laboratories, and he will be delving into hydrogen from nuclear, what are the safety aspects, and also tell us something about the Advanced Nuclear Skills and Innovation Campus that's coming on rather well. So nothing else from me other than to pass you over to Philip. Thank you very much.
Thank you very much for the introduction. That's very kind, and it's a pleasure to be here. I'm sorry that I can't be there in person today. I think where we're going to go today is a little bit about where nuclear could be going in the future. We'll lay out a little bit of a roadmap for what things could look like for the applications of nuclear, and then we'll talk a little bit about how as a sector we can start enabling and unlocking some of the barriers that we may find on a safety and a risk perspective to nuclear being used for a wider range of applications. So just by way of a quick introduction, I've recently joined the National Nuclear Laboratory, having completed a secondment with the Nuclear Innovation and Research Office, where I was supporting and advising BEIS on various aspects of innovation and policy. Moving over to the National Nuclear Laboratory into the new role of technology leader for hydrogen, that really represents the development of the NNL strategy to look at clean growth and benefiting and nuclear enabling the clean energy agenda in a more cohesive way. The National Nuclear Laboratory, for people that are not familiar, is a government-owned but independently operated organisation with custodianship over the national fission capability and laboratories, and with around 1,000 people who are looking at how nuclear science and technology can be used for the betterment of society. One of the unique things in how the organisation is operated is that as a result of the government ownership, we take any commercial revenues and margin, and that's reinvested into the science and technology elements. And some of that is what I'm going to be talking about today. We're in a really interesting world at the moment, of course, of climate change and the net zero agenda. In terms of nuclear energy, we've been reliably outputting electricity for decades, and we are the custodians of one of the most powerful climate change tools that we have, I believe. In terms of how nuclear has developed over the years, we have generally been the second largest producer of clean electrons since we started producing electricity, just behind hydro. So in terms of credibility and in terms of the track record, nuclear is second to not many. In terms of the future, what we see with net zero is an increasing amount of drive to use all of our primary energy, our clean primary energy, for a wider range of applications that can be used for the end users who actually hold the decarbonisation challenges. You know, nuclear energy per se doesn't hold a decarbonisation target as such, and by explaining and articulating how nuclear as a primary energy source can support renewables and other technologies in delivering the decarbonisation end user applications, then I believe that there is an opportunity for nuclear to step outside its traditional baseload badge and move into the more emerging areas of transportation, of the use of hydrogen in heating, for example. So this diagram outlines the potential routes that nuclear has to access those markets. First of all, we obviously have electricity, and there's a big agenda on electrification into buildings to a greater extent, industry, and transportation, of course, with electric vehicles. But the primary output from nuclear energy is heat, of course, and then we use that for a range of different purposes, or mainly it's electricity. There have been examples of direct heat being taken off into district heating in the past, so we have these track records as well. But direct heat at modest temperatures could be used in district heating networks, and the Energy Systems Catapult finds that that's a really attractive way of decarbonising quite densely populated areas. And of course, industry, if we look forward to the potential for high temperature reactors, then the use of direct high temperature heat into industry is a really viable decarbonisation option, which was recognised in policy that we'll look at shortly. Of course, we've got hydrogen as well. And hydrogen has been a subject associated with nuclear for decades internationally, but in fact in the UK it's a relatively new topic, although I do remember picking up on some presentations that were provided in 2005 on the topic of nuclear hydrogen. They didn't progress at the time, of course, but now with the clean energy agenda, we have seen much faster progress, and we'll talk about that into policy space shortly. So hydrogen has got a very broad range of uses, both from buildings for heating, where it might replace methane in the gas networks, for example, of course to fire industry and replace methane in those purposes, and transportation, where electrification and batteries are a limitation. You can still drive an electric vehicle on hydrogen, for example. The electric motors will be driven by electricity from a fuel cell in those instances. Of course, the very recent development here is in the discussion of nuclear for sustainable fuel and ammonia production, where we have some really tricky decarbonisation challenges around shipping, aviation, and heavy transport. So there's been some recent developments on that we'll touch on momentarily. In terms of the direct use of nuclear energy on ships, that's something that we've been aware of, and as there have been nuclear propelled ships in the past, and the UK is proposing to adopt legislation that allows that to be the case in the UK again. So we've got this really wide area that's effectively opening the doors now to nuclear energy to provide its primary energy into all of these decarbonisers. And in terms of when as a nuclear sector we're speaking outside of nuclear, I think it's really important that we articulate just exactly that linking the end users to those primary energy sources is really important, and more often than not I tend to see discussion around end use innovations with little consideration of the primary energy. So I think we have a role to do in that whole piece. In terms of how we got to where we are today, there's been really incredibly rapid progress over the last 2 years in the policy space on nuclear for wider applications. And we see the NIRAB report. NIRAB is the independent advisors for BEIS, made up of a whole range of academics and sector leaders, advising BEIS on where they could take nuclear energy policy. That report specifically draws out the opportunity for a wider range of applications for nuclear energy, and then we saw that kind of reflected to quite a significant extent in the 10-point plan. Nuclear energy is number 3 in the 10-point plan, and there we see developments and commitments around large-scale nuclear, small modular reactors, and of course advanced reactors, with the development of a potential demonstrator by early 2030s. And being number 3 on the 10-point plan means that that really does mean something, and I think we need to be cognizant of that in the sector and recognise that there are these commitments, and government is making lots of positive noises at the moment, in particular around the development of new nuclear. The gas price, of course, very topical at the moment, and it's putting nuclear back on the agenda and on the headlines in a way that we haven't seen for a while. But there are some other sort of very high profile, but perhaps just sitting underneath the 10-point plan there. And in the hydrogen strategy, we saw nuclear described very clearly as a potential route to hydrogen, which is great to see. And there were some specific references there to, in effect, suggesting that government's going to start looking at this area more heavily and including it in some of its standard modelling, which we haven't seen to date. There's then even more recently and even more promising, I would argue, the Sustainable Aviation Fuels mandate, which is currently being consulted upon. And this really flings the doors open, whereby by 2030, it's proposed that the aviation sector has a mandate to use 10% of sustainable aviation fuel. And traditionally, that's been referred to as, bioenergy, or potentially the use of hydrogen if it can be produced from renewable electricity. But in this document, actually, which is the middle one of the three on the bottom row there, in this document it actually articulates that SAF produced from nuclear sources is proposed to be included in that mandate, which provides the nuclear sector with a potential market of around $270 billion internationally. In respect of advanced reactors, moving on to the industrial decarbonisation strategy, there was a specific case study in that document that describes how nuclear could support the direct use of heat into industry. Just linking back to the hydrogen strategy momentarily, if I could, that also comes with 3 consultations, one of which is on the low carbon hydrogen standard. And in that standard, it's proposing that nuclear hydrogen is included as low carbon and will be right there alongside hydrogen produced from other sources such as renewable electricity that can then be sold into a prospective future hydrogen market. So I'm laying the scenes here really for the sector might wish to position itself, and how in this forum, the Risk and Safety Forum, we could start considering what the potential hurdles are to achieving these outcomes. So that brings me on to the Advanced Nuclear Skills and Innovation Campus, which is a new initiative that's currently being funded by the Department for Business, Energy and Industrial Strategy. It's based from the Preston site, so we have the Westinghouse Springfield site, at which the National Nuclear Laboratory has various facilities. And the idea here is that to demonstrate how a collaborative innovation and research approach with collaborators from industry, academia, nuclear sector and non-nuclear sector could bring together and coalesce around a hub for nuclear innovation, focusing on advanced technologies. The concept here is that we bring a skills base, we bring the innovators from academia, we find commercialization opportunities, and also bring together a whole range of different stakeholders to communicate the opportunities that nuclear presents, but also demonstrate that actually, to undertake business and to work on a nuclear licensed site is a very viable proposition. I think there could outside the sector be a stigma associated with nuclear licensed site, but as many of us will surely know, the sun shines and the rain comes down just like everywhere else in the UK. So we're really reaching out on this project with the potential for a follow-on project if this one is deemed successful. And within the programme, there's a whole range of varied activities. There are some funding calls available now on this. So I think some have been out and recently closed, but there are some other feasibility study type projects that are likely to be coming out and released in the near future. So keep an eye out for those, and if you'd like further information, I'll be pleased to provide it. In terms of one particular project that I'd like to look at and focus in on here is the Nuclear Derived Hydrogen to Gas Networks project, which is the anchor project within ANSIC, as we're calling it. And this looks at how nuclear could be producing hydrogen that can be fed into the gas networks. Of course, the distributed nature of the assets on the gas network and relatively small users, millions of relatively small users of gas all around the UK, makes it a really challenging decarbonisation problem. For this, we've partnered with a company called DNV, which is an authority of gas safety and on the network safety. So with all these dispersed users of potentially hydrogen, if the gas networks are successful in converting, of course, and that's something that's ongoing in other areas of this field, we're going to have a whole range of different activities, all connected to that grid. Some of those might be production of electricity from hydrogen for peaking plant. It could be for cooking in homes, to charge cars or transportation, heat homes, and potentially also drive ammonia production for agriculture. But nuclear tends to produce a lot of hydrogen in one place, depending on the size of the plant. And somewhere like Sizewell C, or a plant of that size, so 3 gigawatts or thereabouts, could be producing about the amount of hydrogen that we use in the UK today. So it's a huge amount, and by 2050, that amount could increase by tenfold. The demand on hydrogen could increase tenfold from today. One scenario could be, we have 10 very large point producers of hydrogen, and that needs to get around the UK's users. So what the project that we're delivering at the moment looks at is how you would ensure that the interface between hydrogen coming from the hydrogen production associated with the nuclear power station, how that gets into that grid. Hence why we're partnering with DNV, who understands all the red bit, and ourselves on the green bit, if you like, and that interface is what we're trying to unlock and remove some of the barriers. In terms of the project itself, we'll be looking at a whole range of aspects, including understanding and ensuring that both parties and both sides understand that. So we're bringing in some other stakeholders as well to those conversations. We'll be looking at the safety and regulatory aspects, and of course, crucial to the success of all this, we'll be looking at the economics and what the next steps might be to enable the deployment of nuclear for these specific purposes. In terms of cost, I think it's largely touted that sort of $2 per kilo or £1.50 per kilo of hydrogen is a benchmark to be comparable to sort of the cost of methane as of last year, at least. I've just seen something recently from the US that suggests that they believe nuclear could achieve as low as $1 per kilo, at which point it's massively undercutting the cost of methane, clearly at today's prices, but even at historic prices, which then makes it an opportunity for economic growth as well, to reduce the cost of energy to consumers overall. So, if that could be achieved, and I think we'll be innovating to try and do that, removing some of the barriers, then the nuclear has a very significant opportunity. So part of, I mentioned earlier that NNL has a clean energy agenda. Within that, there's a clean energy focus area, and there's been some recent studies looking at how hydrogen could support the future, how nuclear could support the future hydrogen economies. So we've been thinking a little bit about what the safety implications of siting a hydrogen facility either close to or far from a nuclear licensed site. And some of the questions that we'd put out there are, around the hydrogen production and storage, for example. Can that be close to a licensed site, on a licensed site? Should it be distanced from a licensed site? When we're selecting the hydrogen production technologies, should they be selected based on efficiency and cost, or on the principle of where they're siting and how they're coupling to the nuclear technology delivers a LARP? How can we consider those technologies next to that principle? What can we learn from other sectors in terms of relevant good practice that could be brought in? We, of course, already have hydrogen on our nuclear sites, where it's often used as a coolant in the turbine and generator. So in that respect, how can we learn from what's done already? How can we scale it up and look at the risk associated with doing so? How can we take the fault study and PSA approaches of today, and how would they need to be addressed, updated, and potentially expanded to include this as a potential fault? What are the potential faults and initiators, and what's the impact on the reactor ultimately in terms of the safety case, and enabling regulators to get to the point of agreeing and signing off projects, providing an operating license for reactors that are using and producing hydrogen. How would the nuclear regulators interface with the standards, gas standards? I don't think that's something that the sector's perhaps got its head around at the moment, and that's clearly what the project that we're going to try and deliver by the end of March is set out to do. In terms of then the siting, we understand nuclear and position nuclear in parts of the country, by the sea, away from large populations. But if we had the ability to place reactors in other parts of the country, where might they be? What are the safety implications of doing that? How might something such as TRISO fuel or the fuel for high temperature gas reactors actually enable us to site reactors in a more diverse range of places, and therefore feed into the gas network and the transmission network in different ways and at different quantities? So these are the sorts of things that I put to you today as things to take away and consider. Sort of painted a picture of what the roadmap for nuclear could look like in terms of its diversifying in its applications. And I think to have a successful and thriving sector that provides, great job opportunities for our next generation and brings economic wealth to parts of the UK where nuclear is now and where nuclear could be in the future, we need to consider what are the barriers to this and ensure that at such time that projects come forward that are seeking to do this, and we that could happen very quickly. How would we overcome those challenges and support those developer organisations to achieve that? So that concludes my presentation, which I hope you found interesting. Thank you for your attention. I guess I'll pass back to Jazz, and I understand that there are potentially some questions. Thanks very much, everybody.
Excellent. Thank you very much for that, Phil. That's a really good run through of what ANSIC is set up for and doing. First quick question with ANSIC is, how do we get involved with the type of research you're up to, or can we put projects forward, or as in, how does it work if you're looking for industry to get involved with ANSIC's program?
Yeah, of course. So we will be running a number of sort of outreach activities and communications to make sure that people are cited on this. This, of course, is one of them. But there are a number of calls that have gone out and will be going out to invite innovators to come forward with their proposals. Some of those calls will involve carrying out activities on the NNL laboratories. So, included in that is access to the site, access to the facilities and such like. In terms of then the feasibility studies, that could be something that's delivered from home offices and such like. So keep an eye out on the NNL LinkedIn page, I would suggest, as a reliable source of what's coming through. And there's also, if people are familiar with the Game Changers challenges, so we're using that as a model here. So I think there's a Game Changers website, which I could share, which enables people to have a look and see what the scopes are.
Oh, excellent. Thank you for that. A few questions pouring in now. So one of them is, we know direct or district heating's been used quite a lot and been developed for a very long period of time in Russia, using their VVR technology. The question is, what are the public acceptance issues of having your heating system being supplied by a nuke? Surely there'll be some challenges around that over here. I mean, obviously the Russians accept it over there, but what are the public acceptance challenges?
Yeah, I mean, the potential for nuclear to supply those district heat networks could be, could be incredibly cost competitive first. So in terms of what consumers are looking for, nuclear could deliver that at very low cost. Also, the nuclear facility doesn't necessarily need to be close to these centres of population. I think there's some estimates that a 60-kilometre heat pipe for water of kind of 100 degrees, 120 degrees would be perfectly fine and economically viable. I think even in the Energy Systems Catapult modelling, where they associate small modular reactors with district heating, they propose up to that sort of distance to transport the water and the heat. I think perhaps the question is also alluding to, would this be called nuclear heat, if you like? And I do remember being asked a question once about, well, why would we be taking water from the core of a reactor and putting that into our homes? And I think this is a sort of very much a public communications piece to articulate that that's very much not the case. And, there are several degrees of separation between what goes on in the reactor and the water that we're seeing here, into people's homes and are circulated around. So for me, I think not only in district heating for nuclear, but I think in a whole range of areas, we do have a communications piece to do to enable people to understand. And the evidence suggests that if you explain to people in an appropriate way and to an appropriate depth, and that could be quite a lot deeper than we might expect the public want to know, then I think we can overcome those challenges. I certainly hope we can.
No, it's a very good point. Obviously, in our community, what you've said sounds very good, obviously, because we understand the science, the technology, and how it would be delivered. But public acceptance of nuclear can be tricky. So I suppose there is got to be a communications piece that would have to be stitched together around that to get public acceptance.
Absolutely.
Moving on then. So I'll wrap a couple up together. It's all to do with our gas network and the potential to change our natural gas network into a hydrogen network, because there's already plans on putting 20% hydrogen into the gas network. The question is, first question is, can hydrogen or be as cost competitive as ground source heat pumps and as efficient? Although heat source pumps have had a bit of a negative press at the moment. Apparently your water doesn't get as hot as you like. Having a tepid shower in the morning is not that appealing. So cost competitiveness with hydrogen ground source heat pumps. And then the other one to do with our gas network is that all new build houses post 2025, are they? They're not supposed to have any gas connection. So that surely drives you towards putting in ground source heat pumps and or having a good strong electrical grid connection where the grid is then decarbonised. Any thoughts on those two points?
Yeah, of course. Yeah. So let's think about the user experience of energy, and we don't often think about it like that. We don't often think about how fantastic it is that we have the energy security that we have in this country. But the user experience of using natural gas is very good. You turn it on when you want it, you turn it off when you don't want it. It heats things up very, very hot. And our homes have all been built around that infrastructure. So if we think about conversion of a particular home, installing heat source pumps means massive increase in the insulation of that home, so a lot of interference in perhaps the fabric of the structure of the building, and certainly to people living in it. We then need to think about what people are used to in terms of operating their systems, and people are used to gas-fired central heating. I think there's something like 80% of the buildings that we have today will be here in 100 years or something to that effect. So the proportion of new builds is very, very small. And I just add that the government is about to produce and issue a heat strategy later this year, with then planned for a heat policy in 2026, I think, or thereabouts. And in that regard, I think we could start to see these decisions being taken as to whether there is going to be a drive for ground source heat pumps and all the upheaval that involves, or whether hydrogen may actually be something that's can be cost competitive. There is a long way to go on this. We're only at the very start of achieving decarbonisation of the heat sector. And it's also likely that we'll see a mix of technologies as well coming forward that are suitable for different types of homes and different user experiences that people may choose to adopt one way or the other. I'd also just add, in relation to conversion of the gas network, if that's okay, that since the 80s, I think, or even before, we've been converting all of our networks, so local networks, to polypipe, and those can readily accept hydrogen. So hydrogen has a reputation as a small molecule for leaking, but those polypipes are very good and can accept hydrogen. That's not the case everywhere, of course, so there would need to be some developments, but that's already ongoing. In terms of the transmission network, which are the big spines of transmission that go up and down the country, there is currently discussion going on about whether they would want to be converted entirely to hydrogen, whether they would perhaps include a blend of hydrogen and methane, and then some separation at either end, perhaps as a transition. But I think there is some discussion about needing to change that high pressure system. And when you're operating on the high pressures, then you are probably going to see some leakage and would need to change that out. So there's a significant infrastructure investment here, and having a clear policy and strategy to enable that to happen in a timely way is going to be increasingly important.
Oh, brilliant. That's a very comprehensive answer. Thank you very much for that. We've got time for one final question, and that's all to do with security and tying up the theme of cybersecurity, which we discussed earlier in the day. And it's all around nuclear propulsion ships. So yes, we all know it's a very good idea if we can stop burning diesel to push the cargo around the world, and it's rather intensive in terms of the amount of diesel we use. If you did switch to cargo ships having a nuclear core and being propelled as such, what are the security risks around that, both in terms of physical security of the kit, as in the plant, and also potential cyber threats? And I'm thinking pirates, piracy on the high seas as well.
Yeah, so the consultation out at the moment, so the Marine and Coast Guard Agency has issued a consultation which closed last Monday, I think, that was consulting on whether and how the UK adopts an international treaty on shipping or nuclear propulsion for shipping. This has been available to the UK to adopt into law for 40 years, but it's chosen this year to really consider that in detail. Part of that consideration is naturally going to be the security and non-proliferation aspects of nuclear for shipping. So I agree that is a really important area and something that I'm sure the policymakers and other parties are going to be looking at in quite some detail with a fine-tooth comb. In terms of the consultation that's out, or the consultation that DFT are considering, I think what's interesting is that has emerged very quickly as a viable, their consideration as a viable decarbonisation option, which potentially indicates the difficulty that they foresee with decarbonising shipping. So whilst I agree, yes, the security and non-proliferation aspects need to be carefully considered, and you're quite right, you highlight some of the potential things that need to be looked into. I do think it signals a wider opportunity for nuclear, perhaps in ammonia production, which is a viable conversion from existing ships that are fired on ship fuel into ammonia fueled ships. So we need to look at it in the round, I think, and consider all the potential options that are available for the different decarbonisation challenges.
Brilliant. Thank you very much, Philip, for that. That's been a really good understanding of what are the aspects of hydrogen and what's going on at ANZSIC. Thank you very much for your time today and supporting the Risk and Safety Forum.